one of the wonderful things about computer science is after those first 2 years, when you've gotten through data structures, you're useful. You can already do valuable stuff for companies.
Welcome, everyone, to the TechGuide podcast, where we give actual advice to those wanting to break into tech or are looking for their next gig. We have Dr. Fred Martin on the show today, who is a professor and the chair of computer science at the University of Texas at San Antonio. I'm so excited to welcome on the show today to talk about the programs that they are offering and the importance of experiential learning. Dr. Fred Martin, thank you so much for being here. So excited to have you on.
Oh, thank you, Ryan. I'm looking forward to our conversation today.
You're going to be great. You have a phenomenal background. You've been a professor for so long. So I'm excited to dive into.
Now you make me seem old.
Yeah. Very wise. Very wise. Though. You're going to have a ton of advice. But before we dive into that advice that you have for bachelor's in computer science, master's in AI, all that good stuff, can you give the audience a little bit of background about who Dr. Fred Martin is?
Sure. So I grew up in New York. I was born in Manhattan. I grew up in upstate New York. I went to just a regular high school in the country, really, that had some great teachers. So I'm a beneficiary of our nation's investment in science and engineering and math education that launched with the Sputnik era when the Soviets launched a satellite before we did. So I had some great teachers in high school. I had a math teacher who worked with me and a small group of kids for 4 years, starting when I was in 9th grade through 12th grade. And I was precocious in math as a kid. And so based on the support that I had from this teacher and some of my own abilities, I had the great opportunity to go to MIT for undergrad. And then I loved it so much that I stayed on for all my degrees are from MIT, the degree in computer science and electrical engineering. That's my undergrad. Starting in grad school, I started working with a professor who is very famous, and now he's passed. His name is Seymour Papert, and he was the first person to believe that kids should program computers. And he started this work in the 1960s. I was in the mid 80s when I joined his group. And so back then, computer aided instruction was starting to be a thing. These big mainframes, delivering questions to kids and kids giving the answers. He's like, no, that's totally backwards. Kids should code computers. So he created this language called Logo, which is the first language for kids. So I had the great fortune of working with him and his whole group. I had another advisor for my PhD. His name is Edith Ackerman, who really who believed in listening to kids. So from a grad school years are so formative. I really became focused on thinking about how people learn and listening to people, and working with students, working with kids. So I've built my career around teaching and learning in computer science and now in AI. I became a professor in 2002. I stayed in Massachusetts. I was at the University of Massachusetts Lowell. That's where I built my career for 21 years, getting all the professor ranks and also working in academic administration. And then a couple of years ago, I was like, I want to do the next thing. And I found this job at UT San Antonio, and they brought me here as chair. So this is just starting my second year as chair in a month. So I'm very happy to be here and sharing what I've been doing.
Yeah, absolutely. Well, I'm excited. I'm happy that you are here as well, because I think you're going to give some great context on especially undergrads with computer science, especially because you had your one. And fun fact for everyone listening, computer science and electrical engineering is the degree that you got. I believe that is the same degree that Jeff Bezos got. So you're in the same
there we
company.
go.
Yeah.
I could have ran Amazon.
Yeah. But let's talk about that bachelor's in computer science. Nowadays, people want to go to computer science. There's a lot of reasons to go career-wise. Pretty safe. Trends are there. Good pay. Before someone enrolls in a computer science degree, a program, whatever, what would you advise that they look for in a program?
The first thing to say is, I think, and this is true of most undergraduate programs, is the students who come, some of them have been coding for years and years, like in middle school or earlier. They've just found they found the computer science bug and learn what coding is. And other people are more curious to discover it, and they haven't done any coding, and that's fine too. And then those two groups of people are side by side. So all of the computer science programs like work with these two groups of students, and we really strive to support, of course, the kids who have been coding are going to do great. And we work to support students who are just discovering to code. So our first class here at UTSA teaches you how to code, teaches you how to think like a programmer. And then hopefully after that first semester, you're like, this is kind of fun, so that you get motivated to keep going.
Interesting. So I think it's interesting that they go kind of side by side. And obviously, can you talk about like what that first class like really teaches there, or like what they can learn, especially if it's someone that doesn't have any coding experience?
Yeah, sure. Well, so, you learn how to code, right? So you learn about like for loops and if statements. You learn about variables. You learn how to like drive the computer around as a coder, how to compile and run programs. You also learn what are sort of problems that you can solve with coding. Nowadays, we all know that like low-level coding is already in practice. It's supplemented by tools like ChatGPT. So AI is already part of the practice of coding. So one of the things that I'm interested in, many of our faculty are thinking about, is how can we help students use these tools in a way that helps them learn? Because you still have to understand how the machine works.
Yeah.
And so that first class is starting to teach you, like, to use a car metaphor, what's under the hood, how do the different parts work, and then what sort of problems are interesting to solve.
Interesting. And so that sounds like the first class that you take. Once that first semester is done and someone's like, oh my gosh, like, yes, I want to do computer science. I am hooked, line, sinkered into this thing. What else can they expect in that undergraduate degree to like kind of go through, especially that freshman and sophomore year as well?
Yeah, and that's exactly what we hope for. We hope the first semester is a big success. I will say that for some people, it takes more than one try. I don't know about you, Ryan, but whenever I'm learning a new thing, I know it's going to take me more than one try. I recreationally play rock music, and I've got a new band here in San Antonio, learning new songs. And
cool.
It's like, you just have to practice. And I find it really fascinating that I'll be away from a song for a couple days. I come back to it and suddenly I can do it a little bit better. It's just that repetition. So I really encourage all students, don't give up, keep trying, be patient with yourself. It takes time. And the thing that is hard as a learner is you're often surrounded by people who are already farther along in their learning journey than you. And so I just always remind students when I can, just give yourself time. That person who seems like they're smarter than you, it's probably just they've been at it for longer. So be patient with yourself.
Yeah, absolutely. I feel like a lot of being of success in undergrad and even post grad comes down to just repetition and getting those reps in. I think it's the Malcolm Gladwell rule of 10,000 hours to actually get proficient at something. So it's not expecting to be good right from the start.
That's right. Yeah. So there's a pretty typical sequence in computer science programs across the country. The first 3 or 4 classes are pretty much the same. Here at UTSA, what we do is the first class is just the coding that I described. We do the first 2 years in Java. So we like to keep a consistent language so that people feel grounded. So the first class is coding. The second class is a thing called object orientation, which is how all modern software is designed these days. So that's the second class. For the third class, we actually do introduce you to another language, the language C, which is these are both the most prevalent. You'll code in other languages in your career. Another foundational thing in our program here, and this is typically true in CS programs, is we're teaching you how to learn, because the languages that you use now, they might be there, but you're definitely going to be learning new languages. And so that's an essential skill as a computer scientist, is the ability to learn new languages. So we give you a grounding in these fundamental languages, C and Java. The critical class it's a class called data structures, which is about how do you organize data in all different ways? How do you make lists of things, arrays? There's trees is another key data structure. And then what are their properties? Like, why would you choose this data structure versus that one? How do you manipulate it? That's a sophomore class. And pretty much if a student makes it through data structures, then they're home free for their degree.
Interesting. I want to talk like how important is, I want to go back to something that you said a little bit earlier, building that foundation when it comes to computer science. Can you talk about, I mean, I'm sure the foundation is important for everything, but like, let's talk about why it's important to build that foundation in languages like C++ and Java early on.
Yeah, sure. Well, so like part of it is understanding how the machine works internally. So that's why we teach the C language, is because it's a low level language. So the language like reveals the underlying structure, whereas a language like Java is more higher level. So it actually deliberately insulates you from that low level details so that you as a coder can work at a more sophisticated level. But for students to be able to like do anything, you do have to know how the machine works. So learning the C language is a typical way, and that's how we do it to give you that foundation.
I like it. So once that foundation is built, it sounds like basically once you've passed your sophomore, junior year, you're home free, basically, as you said. What are some other courses in those junior and like senior years that students could expect to take?
Yeah, absolutely. So then there's all the application areas. So we teach you how to build mobile apps. We teach you about databases, and some of these are requirements and others are electives. We have a strong cloud computing concentration here at UTSA. Of course, there's also AI and machine learning and data science. These are all electives, and electives that if you focus on, you can get like a concentration, which is a formal acknowledgement in your degree. We also here on my campus, we have a strong foundation in software engineering, so how to build software. We have a number of faculty that do that in the research area, and then we have advanced courses. So just as you were suggesting, Ryan, these are junior and senior level courses. And we also, the other big strength we have here in San Antonio, the city, UTSA, my campus, is cybersecurity. San Antonio is the second largest concentration of cybersecurity and security related jobs outside of Washington, D.C. Yeah. So it's a big center here.
Very, very interesting. I like how you guys like help. It's more like actual application of like what you're learning, of like building mobile apps and actually getting them experiences to like, you learned out like the foundations in freshman and sophomore year, but your junior year actually like putting that into practice and building stuff like mobile apps.
Absolutely. Maybe we could, this is a segue to talk about a big part of what I always recommend to students is it's more than classwork. You want to so we do our best and we do a good job of getting you involved in solid projects as in your courses, but there's nothing like having a real external client. So I always encourage students, look for an internship. And one of the wonderful things about computer science is after those first 2 years, when you've gotten through data structures, you're useful. You can already do valuable stuff for companies. So that is a prime time to look for an internship is after your second year. And then, of course, you start looking the fall of your second year because companies are recruiting then. And so we call this in higher ed, we call this experiential learning, which is learning through real experiences like an actual job. So we have a lot of partnerships with companies. We have a career center, all these resources to help students find that internship, ideally after their second year.
Yeah, absolutely. And can you talk a little bit more about like those resources that you give in those partnerships specifically that you guys have? Because I want something to like, that's listening to this and it's like, oh, I might go to UTSA. If they're like, listen, there's like, oh my gosh, they can like really set me up for success like after school. Can you talk about that a little bit more in depth about like the internships provided and why it's so important?
Yeah, sure. And for people who are listening, this is true really at every college does this. A big part of the value proposition of going to a 4-year program is the network of relationships that you develop through that program, the longstanding relationships that your school has with the regional employers and national employers. So we do have the big national companies like Google and Facebook Meta and other like top flight companies that come and recruit our students. And we have local companies and everything in between. At UTSA, we also have a lot of relationships with the service sector, with the military and government jobs. And so if those are the sort of things you're interested in, we're a great place to come, including the National Security Administration, if you're looking for that kind of job. So like knowing what sort of relationships your school can offer is a big part of choosing a school.
Yeah, I really, really like that. And I feel like, I mean, having a plan laid out for you where you do have a college that has like those connections with the Googles and like the Metas is like so important. And especially in computer science, can you talk about like the importance of, do you need to internships leaving college to like land a job? Can you talk about like what you'd advise for learning in an internship form, or are there other ways through clubs and stuff?
So I would say you don't need them, but they definitely help a lot. I mean, it puts you to the front of the line when companies are interviewing you, because you can talk about your experiences and they, and the companies can see that. In addition to having an internship, another thing that I advise students to do, and we're investing in this on my campus, is a research appointment with a faculty member in their research lab. So these are also real projects. Faculty members have external grants. They care about these things getting done. They have partners that they're working on. So these are real projects. And typically in a computer science department, you're writing code as part of the professor's lab and you're writing a paper. And you learn a lot through that process. So those are also valuable experiences. The ideal thing is for a student to have one of each, to have a company experience and a research experience, because the research experience also sets you up. If you think you might want to go to grad school and higher ed, then you get a taste of what that is as an undergrad. Of course, that's how I got where I am, as I did that when I was an undergrad.
Yeah, absolutely love that. And volunteer experience as well. I want to make sure we hit on like all the buckets here. I know volunteer experience for me when I was applying for jobs was like humongous, because I actually I was very involved with Special Olympics in college, and that was like a great resource for like actually talking about experience and stuff. How important is like volunteer experience when it comes to like a computer science program? Does it still matter as well to build those interpersonal skills, or how do you advise that?
I think it's valuable, but like most students, it's better to get paid, right? Because you probably need the money. So, and then computer science is a field where there is money to pay. There's certain fields where like in order to get that experience, pretty much the story is you need to volunteer. That's less true for computer science. But it's certainly, take advantage of things. And if you have the time that you can donate your time, that's definitely worth doing.
Absolutely. I want to talk about a master's in artificial intelligence. I know that's a program that you guys are offering as well. Let's talk about like how, if someone comes in, you're like, man, I'm thinking about getting my graduate degree, my master's in artificial intelligence, and what are like a few questions you're going to ask them to see if it's a fit for them? Yeah,
sure. So one of the unusual things about computer science as a field is, and like this is, I'm allowed to say this, even though it's sort of not the party line, you don't need a master's to get a job, right? Like schools, of course, it's like, a good fraction of our revenue is from master's programs. So master's programs are a great thing. But if you have an undergrad in CS, get hired and then let the company pay for your master's, right? Do it part-time. Master's in AI is different though, because this is for career changers. So this is for people who probably don't have a computer science degree. Maybe they have some coding experience. They ideally do have some STEM background. So they have some math, engineering, and then they want to, because AI is a CS adjacent field. So, and a lot of AI is, you're not so much writing code. You're building models. You're building real systems, but you're not like low level coding. Yeah. So it's a great way to open up new career opportunities if you're coming from somewhere other than computer science to get started.
Interesting. What are those career opportunities that it like does open up, just so someone can like think about those opportunities that it does open?
Yeah. So for example, we have a partnership with UT Health, and we have a number of MDs who are going through our MS in AI program. So like AI is being used in all fields.
Yeah.
So understanding how, how models work, how machine learning works, how do you train a model? What are the biases that models have? What are the things you need to be cautious about? And then what are the opportunities in your field? So I think it's basically every field is using AI. So if you understand how AI works, you're just going to be more effective in your field.
Yeah. Yeah. We've had a few people on here that have gotten their masters in AI, and they just said like it really did propel them forward, obviously, because you have your master's degree, but it opened up so many doors to like startups and stuff, because startups are so hungry for people that know like artificial intelligence to actually be able to apply it in their usage case. So I feel like something like that is like so valuable if you are wanting to really take a step in your career. And I feel like it could unlock doors to basically any industry.
I think the key thing in being effective with AI is both the AI knowledge and the domain knowledge. So if you're a working professional, you have experience in some sector, and then you learn about AI, then you could combine those two things. And that's what you really need in order for AI to be effective.
Yeah, absolutely. What are some like courses that you guys teach at UTSA that like helps with that of like domain knowledge and just like the actual practice? Or can you kind of take us through the coursework there?
Sure. So in the MS and AI program, so we have a data science course. So that's a foundational one. So learning how to work with large amounts of data, knowing the different techniques for processing and organizing data. It's called data cleaning, which isn't the most elegant term, but when you have a set of data, there's a bunch of stuff that's going to get in the way, and you've got to like get it out of the way.
Yeah.
Understanding what the tools are in order to do this work, creating visualization. So that's an example of a foundational course. One of our more advanced courses is learning about large language models, the things behind ChatGPT. So what's amazing about LLMs is that they can cross boundaries. They're not just about language, because you can interface them to physical things, to sound, to images. So it's sort of amazing how powerful a tool LLMs already are and will continue to become.
Yeah. So I feel like AI is probably like the hottest industry to get in right now, just because relatively it's still like a pretty young industry, or in case the steps that have been taken in the past like 5 years with it. And I feel like people are like flocking to these industries to like learn these skills, these jobs, because in a few years, like, I mean, AI is everywhere, but like AI will continue, and being able to actually apply this stuff is like super valuable.
I had some medical testing done recently, and the doctor was reporting on the results, and she was telling me it said, well, it basically, there was an interpretation of the results on my chart, and I was saying, who made that interpretation? Because it sounded like it was some other I assumed it was some other tech who read the graph, and then she's reporting me on what the tech said. And we went back and forth, and finally she was like, oh, the device outputted this. So she was telling me the device's interpretation, right? And it's kind of older medical tech. It's not even AI. It's been around for a while. So like already, like these sort of machine interpretations of data, we've been living with them for a long time. We're just like realizing that it's going to be more and more.
Interesting. Going off of that, like, is there an industry that you're most excited for the application of AI then?
I hope that like in the energy sector, that we can have more energy efficiency with the use of AI, because that's something that's just a win-win. I'm old enough to remember the energy crisis back in the 70s, and then it was about conservation, and it was basically about being less comfortable because you had to turn down the heat. But now we don't think about it that way. Now it's like we can use technology to still like have the style of life that we're used to, and save energy. We can be much more efficient. This is something where AI can really contribute.
Interesting. Yeah, I feel like there's a lot of like good industries that someone could get in, but it's kind of choosing which one is probably most impactful for you and like what you want to do with your life, especially when it comes to AI.
Yeah, I want actually, that sort of reminded me, Ryan, of something I always coach students, particularly undergrads, because a lot of the undergrads at like a school like my school now and my prior school is that like they're working class kids, probably they're students who their parents didn't go to college. And mostly they're looking for college to get a good job, to provide for themselves, for their families, their parents and siblings and their future families when they have kids. So their main goal is like, I want to get a good job. And that's wonderful. I want them also to think about what do I want to contribute to the world? So what type of job do I, what you were suggesting, what industry do I want to be in? Because there are a lot of choices, and a lot of students go for the first offer they get.
Yeah.
And that's okay. And if you're able to like be like more deliberative about like where you're looking, then that's what you find.
Interesting. How do you be more deliberate on like where you're looking? Like what variables do you need to take into place, or how do you be deliberate on like what would be a good fit for yourself?
So it comes back to what we were saying earlier, is to get that internship early. So because that will open doors to others. And if you've made it to the end of the degree and you haven't done that, well, then taking the first thing might actually be the best move. And most recently there's a little bit of a, drawback with like a few years ago, you would get multiple offers.
Yeah.
Now getting that first offer is work. So it's just as best you can getting the experiences early so that you have choices later.
I absolutely love that. This has been an incredible experience for me on this podcast to like learn from you. We are kind of winding down on time here. When it comes to like UTSA and like what people can expect, like what would you tell someone like, hey, I'm considering going to UTSA. I think you guys would be a great program. What would you tell them and get them to the final push? Yeah.
Most of our undergrads are from Texas. So if you're a Texas student, you're welcome. If you're from anywhere, you're welcome. We have international undergrads. And of course, a lot of our grad students are international. We have a really strong student clubs, particularly for undergrads, also for grad students. And the clubs really also offer a lot of opportunities. But the thing I always tell students is visit and talk to people. And if you feel like these are your people, then you'll be happy.
I like that. Let's end it right there, Dr. Fred Martin. Thank you so much for joining us. Last question for you. If like, oh my gosh, get me to UTSA right away. Where can they do that? Where can they find you, and where can they find UTSA?
Sure. Well, if you just do a web search on my name, Fred Martin, and UTSA, you'll find me. And our URL is utsa.edu.
Awesome.
And please be in touch. And anybody who's watching this podcast and you want to get in touch with me, please do.
Awesome. You're the best, Dr. Fred Martin. Thank you so much for being here today.
Thanks, Ryan. Thank you.